just start this one with this thing. You're given n by n grid where each cell has one of three values. 0 is empty, 1's fresh, and 2 is rotten. And basically at any minute, every minute, any fresh orange that's 4 directionally adjacent to a rotten orange becomes rotten. Return minimum number of minutes must elapse until no cell has a fresh orange. So basically a fresh orange is 1 and 2. So it's almost like a BFS where you corrupt each island with 2 and then you run a check to see so what is a minute, you know? So you would do a BFS on islands and then every time you burn, so minute 0, minute 1 is you have another layer, another layer, another layer, another layer. So basically how many fringe layers do you have before you have no more children, and then if you have no more children then you count that. And so if there's like a bunch of islands of oranges, then you just keep the running maximum of it and then return the running maximum. And then so if there's no oranges to corrupt, or there exists some, and then we might just do a check across the entire grid after to say, well, if there exists a 1, then return -1 after corrupting everything. I don't know what. Oh, okay. So 2 is rotten. Okay. So rows is like length of grid. Columns is grid 0. Range calls. Okay, cool. And then we say also need a visited node if this is kind of hard. Minimum number of minutes. Oh, maybe this is just DP. Why do I need to BFS? So I go here and let's say this is 2. I just have a copy of the array. This is 2, and so the time here is 1. The time here is also 1. And then here the time, but it's 4 directional. So because you have X and X, then BFS is very hard. Like 1, 1, 1, and then 2, 2. But that only propagates information from like top left to bottom right, but not vice versa. So for example, 1, 1, and then 2, and then maybe there's another rotten thing here, but that would have infected this with 1. So we probably need to do a 2 pass like this and then back up and then look at the minimum. So actually for I in range rows, dp dot append this many columns. Perhaps I just want to do float infinity. Oh, I need to print stuff. dp. Okay. Corner cases is if it's no, it's not a corner case because then we update dpij to be 0, sorry, to be time 0 if grid ij is 2. Yeah. So okay, cool. Check if there's even any no fresh oranges. Right. What if there's some that, oh, okay. Infected via looping over dpij, and if not infinite, if grid ij is 1. That means there exists a fresh orange, even though it's never been infected. So j in range columns, then you would say if dpij is rotten, then go ahead and do grid, and dpij is gonna be 0 because that's the source of the rottenness. And then else if it's 1, so it's a fresh orange, then go ahead and take grid, the grid is 1, then take tp I of j minus 1 min of something dp I minus 1 j plus 1 and or dp ij minus 1. Start your main loop. Probably some edge cases with so if this is if I is 0 and j is then I can only take information from the previous row. There's no minimum required because so if these are untouched, they're infinite. So if they're just not a source of infection, then that's fine. Then it's just the minimum infinite, so it's infinite. So like nothing gets propagated. If I was 0, then we just take so if it's infinite, then it'll just propagate infinite, so nothing happens. If it's 0, then it'll just propagate 1 as in 1 minute. And then if dpij is dpij minus 1. Wait, so no, j minus 1 previous, and then 1 minus 1. So j is if j is 0, then I would take the previous thing. If I is 0, then I would take the left hand side. Okay, cool. I kind of want to print dp first, just so that I'm not going insane. So I'll need to take the maximum. Yeah, I'll need to take the maximum non-infinite number. Okay, so now I need to propagate it the other way in reverse. I don't know of an elegant way of doing this. If anyone knows, please let me know. This is already done, but that's fine. Too lazy. If it's 1 and look to the right, and then look to the down, and if I is number of rows, columns, then go ahead. So if I is the end, then look to the right, and then if I is number of columns, because you can't look down, and then if j is equals columns, you can't look right. So you want to be able to update this. Oh. Right, because the edges are touched here. Okay, here then you do have to do dpi j. Because this had a pass already, so. That's not good. Oh. So I guess since this second pass, we do need to consider that it's existing value. So this is right, 0, 1, 2, 1, 2, and then 3, 4. All right. So what is the actual answer? 0, and then for I in range, rows for j in range, calls if dpij not float of infinite, then my max equals max of my max dpij. And then also non-infected equals false. And if dpij, I also want to check if it is infinite to make sure that if grid ij is a fresh orange, then actually we can just return -1. I was going to put a flag in, and then so now we can just say if we don't return a -1, then return my max. This, okay. Print dp. Inf 0. So, okay. 1, we don't do anything, and then we don't do anything, and then but this pass I'm surprised. So for ij, this is 0, and then else if grid's 1. So this is 0, and then this will go ahead and go to the 0th column. And so if I is less than, so I equals well, both these. So rows is 1, so it would just go here. So it's the minimum of this plus this j plus 1 plus 1. So how come this 1 doesn't get propagated? Unless I wrote this wrong somehow. This is number of rows is 1. And what? I equals rows. Oh my god. Is that true? So if I'm on the last, I really hate like these stupid index things because they're not interesting at all. Okay, I is the last row and j is less than. This is how I can look to the right. And this is how I can look down. So I is less than rows minus 1. And then it must be true that j also like this. And I like this. And so let's submit again. Yeah, I really wish like their test cases were not really terrible and impossible to debug. Like if they're gonna put a corner case in, why don't they just do it in a smaller array? Oh, okay. Yeah, this whole solution is wrong, so. because you can have 1, 1, 1, 1, 1, 1, 1. One, one. So it is a BFS. Because then you would infect these. Well, what do you have a snake? Then it doesn't work. So you can infect this, infect this on the first pass, and then you would infect this and this on the second pass, but then these would have a false positive. So it is a BFS. All right, ignore. Okay. Interesting. So more indexing things, which I hate. Okay. This is the hard part, the current coordinate. Current coordinate is row, column, and then you just want to do, you know, do I need current coordinate? I don't know. Answer row column equals I. If it's a 4, then we're gonna want to go to 2. If it's a 3, then we want to go to 1. And then is gonna be so spiral num 0 and then spiral num one. So spiral num 0, and then we say if I'm going back up, I'm gonna need to modify my how far I can go. So spiral num 1 wants to go back to row 1, and then also stops shy of this thing, and then spiral num stop shy of this thing, and then stop shy of this thing, and then spiral num 2 like this. So if I have a length of 5, I floor it so that spiral num 0, spiral num 1, spiral num 1, and then going back up, I say spiral num 2. But I can end at row equals like this. Suppose 4 by 4. Spiral num 0 does this, spiral num 1 does this, and this, and this. So what's 6 look like? Spiral num 0, 1, 2. I would just say end at so let's see. So this just says go to this. I'll just keep rotating this spiral thing basically. So yeah. So vec index 0, 1. So this will update the coordinates. So if vec index is 0, while chord 0 is so I start going right, which is 0, and then I would do like go from here, yeah, I don't know, that row call is super duper necessary. Okay, so I would go to the right, and then do 1, 2, 3, and then go down. So 1, 2, 3, minus brain not working. Right. So while this, okay, then, yeah, so if coordinate so if my column is like this, spiral num is 0, then just keep it, else don't do anything. Actually, I can be more precise and say if because I know I'm adding, so I know I'll eventually hit it and break. Then I don't have to corrupt my coordinates. Okay. Then just do this. Now I'm going down. And yeah. So now I change direction to going down, which means that this will keep incrementing, and this means that we actually care if coordinate 0 hits the spiral num. If it does, vec index plus equals 1, and then else if 2, probably a much better way to solve this, but whatever. 2 is we're going to the left, and then this is going up. Yeah. So right, down, left, up. Okay. So this will keep subtracting. So then if this is just basically spiral num, then I break out of it, and then we'll go ahead and then do vec3. Here, careful, it's actually reset back to 0. And then now I'm going back up. When I finish with this 2, I do need to do spiral num plus equals 1. And then if cur chord in visited return return answer. I don't know that, like tuples are nice, but yeah, it's immutable, so. Okay. So yeah, when I go up, I'll update my spiral num. So here it will go to spiral num. If I go right, so just back to this. If I'm going to the left, then I am mostly concerned that my column is when it hits this 0, update to 1, and now I'm going up, and I am concerned when my row hits 1, and then when I hit 1, my index is 0, and I'll start going to the right again until it hits, basic 2 minus 1 in this case. Yeah. Let's see. I'm curious. I'm pretty sure this is buggy, but I'm curious what this looks like. Will this actually allow me to do this? Yeah. Oh my god. This fucking syntax. So I would need row call equals 0. And this should just be row call. And so I'll just I just need to refactor this. Oh, actually, I should probably just do. Also, probably want to print. Oh, actually, I need to do this before the update. Actually, ideally right under the answer here. And I want to print well, it's probably fine to print visit it instead of like every iteration. Zero, 2, 1, 2, and then 2, 0, 0, 0, 1, 0, 2, 1, 2. Okay, never mind. This is useless. Why doesn't this? So 2, 1 should have been added here, right? So oh, because this only looks at this. Yeah, I wish there was like a cleaner way of doing this. Yeah, I could have probably just made it so that instead of this while true, like have an iterator and just like do this and then check the conditions and then just do a for loop that like I originally intended and have just sit yet wrap around, but whatever, we're here now. Yeah, it's really hard to think about the entire solution and then how to structure it before you even start, but then that's also like the thing that makes things fast. So anyway, where was I? Oh, every time I stamp it, I need to do this. I can also return if I equals if I equals n plus 1. Also don't really want to like add any more lines to this code. Okay, 6 minutes to do this. But I don't even know how I would do it in BFS, you know? Because if you have x and x, then you BFS from this point. Then you say, well, this is a 3, 4, and then I guess as you BFS on the fringe layer, you would just say, oh, the minimum of whatever. Yeah, I guess that's true. 6 minutes, huh? All right. So yeah. Then I do yeah, I guess I don't. I have no idea how to do this, because if you do a fringe layer and then you search, you need to mark as visited, so otherwise you go back. So then what do you do if you encounter, if you have x here and x here? Then you propagate it and cool, but now these are all marked visited. Or perhaps each time around, like after you do this, then you go to the next one, and you go to the next one, then you clear your visited. So yeah. Alright, very low probability, but you know, why not? I'll just use array so it's mutable. For D directions, then I want to add 1 to something. I probably need something Um, that I had before, so it's actually pretty close. Instead of DP, you just do, you know, EP. Okay, depend slope of infinity times c, 2 minutes, impossible. And then so if also need to find direction, so dpij is 0 and if it is equals to 1, then what do we want to do? We want to go ahead and do dpij equals probably doesn't work, but whatever. Oh, and then it does. Just let me have one more error. Alright. Alright, well that was quite the lame thing. It does pass a lot, but yeah, DP's, I guess note to self, DP's not a right approach. And that's kind of annoying thing with grinding so much, like everything looks like a certain set of problems that you want to get better at. So yeah, well, this is interesting. This is like kind of tail heavy. You either have a threshold and then you're pretty good, or like this is like kind of like the valley of despair. You grind, and like you're kind of getting worse and worse because there's so many different new ideas in your brain that you think a solution works, but then you're not too familiar with all the boundary edge cases. So you end up with this and you waste a lot of time finding the wrong solution, and then you go back. But after Valley of Despair, you kind of go back up. I feel like there's some clarity at the end though. When I was coding, like, I don't know, but yeah, not looking good at all for the next round of interviews, but whatever.